these are the answers to the fun pack. We'll see how much fun you had with it, but we're supposed to sketch sine x, cosine x, and then look at the area between them and the y-axis. So sine x goes like this, cosine x comes down like that. They intersect at pi over 4, because that's when opposite and adjacent are the same. All right, so we have that for that, and the y-axis is here, so we're looking at this region right there. Cosine is going to be the top function, and sine will be the bottom function. All right, so we've sketched that and shaded it. So can we set up a definite integral that represents the area? Well, that would just be the integral from 0 to pi over 4 of top function minus bottom function dx. So then number 3 says, evaluate that integral by hand, use your calculator to check your answer. So the integral of sine would be negative cosine, and the integral of cosine is sine. All right, we're gonna go from pi over 4 to 0. So then if I put in pi over 4, we get negative, so for pi over 4, if you go back to your special triangle real quick, that's a 1 square root of 2. So the cosine and the sine are both 1 over square root of 2. So we're going to get negative 1 over square root of 2 minus 1 over square root of 2 minus, and then if I put 0 in, the cosine of 0 is 1. So we'll get negative 1 minus the sine of 0, which is 0. Okay, so that's going to give us negative 2 square root of 2 minus negative 1, so plus 1. We end up with 1 minus 2 over square root of 2. So that's our exact answer, doing it by hand. Let's take the calculator though and check. So first off, I'm going to do 1 minus 2 divided by square root of 2. And we get that decimal there. That does not make me feel very confident. It shouldn't be a negative area. But let me do the math 9. And we might have an issue. We're going to see if we can find it real quick. Okay, so this is what we end up with that for the area. So let's kind of go back and see what might have happened here. The integral of sine, negative cosine, derivative negative cosine is sine. Oh, I have bottom and top switched, so that's part of it. But that should have just made it a negative. Oh, so let me go, so I've done 2 things wrong. You get to see both of them. I was in degree mode. So if I go back and try that again, I bet I'm gonna get the positive. Yep, so I get the same answer I had above, but the problem is that it's not sine minus cosine. It's supposed to be cosine minus sine. So we're gonna flip these around here. And that flips everything else around. We're going to end up with so if I flip that around, the integral of cosine is sine minus the integral of sine, which is negative cosine. So it ends up being sine plus cosine, pi over 4 to 0, which will then give us positives here and a positive, and then minus positive, which will give us a minus there. So we end up with 2 square root of 2 minus 1. 2 over square root of 2 minus 1, which does check out then. All right, so we ended up getting there. My fault on the initial setup. All right, suppose this region above is revolved around the x-axis. Set up a definite integral that represents the volume. So for that, since we're going to spin this around the x-axis, the big radius would be from here all the way around. The little radius would be from here all the way around. And so we're going to have pi times from 0 to pi over 4 cosine x, I'll get it right this time, squared minus sine squared, sine x squared, dx. All right, and so that's what we have there. Number 5 says, can you evaluate that by hand and use your calculator to check your answer? Now this one would be a little more tricky because we don't really have anything for this. and the integration of that is a little bit more than we want to do, especially at the end of the year. So we're going to get rid of that by hand, and we'll just simply put this on the calculator. So pi math 9, 0 to pi divided by 4 of cosine x, I'll put that in parentheses, all right, squared minus parentheses sine x squared dx. All right, 1.571. Looks like we get pi over 2. That would be my guess as to what that is. And again, how do we get that by hand? Well, we can look that up later and see if you're really, really curious. I'm guessing late May you're not that curious. All right, suppose the same region in number 1 is revolved around the y-axis. Can we set up an integral that represents the volume of the solid? So now we're taking the same region, but we're spinning it around the y-axis this time. So because of that, let's use a shell method approach, which is pretty easy for that kind of thing. In shell method, we're going to go 2 pi from 0 to pi over 4, and we're going to do the height of the rectangle, which is cosine x minus sine x, times the distance from there to the y-axis, which is x. Right, and we get that right there. All right, so then use our calculator to evaluate that. So we'll go 2 pi math 9 from 0 to pi divided by 4 of x times cosine x minus sine x dx. And we get 0.696 for our answer there. All right, so that's that answer there. All right, finally, suppose the same region is revolved along the line y equal 2. So that'll be an integral that represents the volume, but we won't evaluate this one. So if we go around the line y equal 2, that's up here. So now the big radius goes from here to down there, and the little radius goes from here to down there. All right, an old idea. We're going to just do pi from 0 to pi over 4, and the big radius will be 2 minus sine squared minus 2 minus cosine squared dx. All right. Next one here says consider this region that was bounded by y equals 0. That's the x-axis. X equal 4, which is this line right here at 4. And y equal 4 times e to the 2x. Now, if I put 0 in for this, I'm going to get e to the 0, which is 1. 4 times 1 is 4. So it's going to start here at 4. And it's going to go to here. And eventually hit this, which will be 4e to the 8th, some very large number, but that's what's going to be up there. All right, so this is the region we're working with. We sketched it, shaded it. We're ready to move on. Set up a definite integral that represents the arc length of this over the interval 0 to 4. So arc length is from 0 to 4, the square root of 1 plus the derivative. The derivative of this would be 8e to the 2x. Squared dx. So there's our integral, and then use our calculator to do that. So math 9, 0 to 4, the square root of 1 plus 8e to the 2x squared dx gives us 11,919.863. Okay, pretty long distance. So now the next question says, can you set up an integral representing the area of the surface of revolution formed by revolving that same? So this one we're going to use one of our formula sheet things here. We used arc length just a second ago. That one was a little more familiar. Surface area is going to be 2 pi times the radius, which will be the actual function, and then times that same arc length formula. So we're going to go 2 pi from 0 to pi over 4. I'm sorry, from 0 to 4 on the old problem there. Then we have the function 4e to the 2x times the square root of 1 plus 8e to the 2x squared dx. Okay, so use our calculator. So here's the nice thing about that. We can just go grab this, and I can go way into the front of it and insert 2 pi, and then go into the front of the square root and insert 4e to the 2x. And we're probably going to get a pretty large number, I would guess. Yeah, holy smokes. 44, 6, 6, 6, 4, 5, 8, 8.5. So 446,664,588.5 square whatever units we'd be working with. All right, now find the centroid of the region sketched in number 9. Show all the integrals used, but evaluate them using calculators. So the first thing we need is what we'd consider, or we would call the mass of it. And that's just the area of it from 0 to 4 of 4e to the 2x dx. All right, and so if we go math 9, 0 to 4, 4e to the 2x dx, we're going to get 5959.916. All right, I'm going to set that equal to a. So I'm going to go on the calculator. When I put that in, I'm just going to simply hit store. It'll take the answer, put it into a. That way I don't have to keep retyping it. All right. Now, as far as the sum of things in the x direction, so when we say sum with x, we're using the y-axis as the center point for this. That's going to be the integral from 0 to 4 of the distance from there. So again, if you think about it like a rectangle, and you say, okay, what's the mass of the rectangle and how far away from the y-axis is it? So that would be x times the height of the function, which is 4e to the 2x dx. Right? So that is using this formula right. Sorry. So this one is, the formula sheet says my because you're using the y-axis as the center line. So sometimes I use it as a sum of the x, but I don't want to try to confuse you here. We're talking about the x coordinates here. So this is what we'll have. And if we divide that or work that out, the nice thing again is I can come up here, grab this, and insert an x in front of that. And we get 20,867.706. Now, right away then, and again, that's what we call the moments about the y-axis. So our x coordinate of the centroid will be that number, y divided by the mass. So in other words, I'm going to take that answer and just quickly divide it by alpha a, and I get 3.501. All right, so that's the x coordinate. So on my thing over here, about 3.5 is where that center of mass is going to be. And then the y coordinate is going to be way up there. So for the y, we're taking the moments about the x-axis, or another way is to sum up all the stuff in the y, and that's going to be 0 to 4, and it's going to take half of the distance, because we're going to be in the halfway point of that rectangle. So 1/2 of 4e to the 2x times the height of it, which is another 4e to the 2x. So this is the times right there. Now you could have just done that squared, of course, but that's what we're going to have right there. So on the calculator, I'm going to go math 0 to 4 of 0.5 4e to the 2x squared dx. Okay, and this is going to give me a pretty large number, 1777221.904, and the y coordinate then will be that divided by alpha a, which is 2,981.958. So our centroid our centroid will be 3.501, 2,981.958. That's the center of mass for this figure. If you went to that number, whatever it is, that would be where the center. Now that doesn't look because I'm on a scale. This goes way up into here, and that's why it's probably more likely to be like this by perspective. But that's our center of mass for that. All right, 15 says this is the base of a solid where each cross-section taken to the perpendicular to the x-axis is a rectangle whose height is 3 times the length. Set up an integral that would represent the volume. Well, the base of that rectangle is going to be 4e to the 2x. The height of that rectangle is 3 times 4e to the 2x. All right, set up an integral that represents that, but don't solve for the integral. There we go. That's pretty easy. All right, then we get 16, and we've got some force problems here. It says the force of 40 pounds is required to stretch a spring from its natural length of 3 feet to a length of 8 feet. All right, so that means the force, 40 pounds, was some constant times the displacement. We went from 3 feet to 8 feet, 5, so that means our K value is 8. So that gives us an equation of force equals 8 times displacement. All right. So find the work done in stretching the spring from its natural length to a length of 12 feet. So that's going to be the integral from 0, from the natural length to a length of 12. 12 is 9 feet of displacement, and we're going to integrate our equation that we just found. Right? So it's as simple as that. We could even do this by hand, 4x squared from 0 to 9. And so it's 9 squared 81 times 4, which is 324. In this case, it's feet pounds, which I know sounds weird, but that would be our thing. And again, if you just, because I made a mistake earlier, I'm just going to check. I'm sure this is fine. All right, there we go. All right, now from a length of 6 feet to a length of 10 feet. So the only thing, the same equation, the only thing that changes here is that the natural length is 3 feet. So if we're going 6 feet, that's already 3 feet of displacement. And then we're going to a 7 feet of displacement. All right. So that's what we're going to get. So 4x squared from 7 to 3. So that's 49 times 4, which is 196, minus 9 times 3, 36. I believe we're going to get 160 for our answer there, but again, let me just check since, yeah, and that's our answer.